Yeah, it doesn't say, so I think we can just do day.
Have you like probably a day or two behind,
Really?
or at least a day behind?
Mhm.
But so I haven't watched any of the videos or read the text, I don't think, for these problems.
Okay. Well, work is super easy.
Yeah.
Um, have you ever done?
What'd you say?
Have you ever taken a physics class?
No.
Okay. So it's it's actually something that we're learning in physics right now, but it's really not bad at all. So all you have to do is um, there's a rule that says the amount of force um, on an object is equal to a constant times the distance, meaning the change in distance.
Okay.
So, and then you use that to find um, the work done, like the energy that's needed, um, and that's the distance squared times that um, value of it. If we go through it, it's a lot easier to explain. So, um, do you have the worksheet pulled up?
Yeah.
Okay. So, um, so it says a force of 10 pounds is required to stretch a spring 4 inches beyond its natural length. And then it wants to know how much work is done stretching the spring 6 inches from its natural length. And then um, it wants to know, okay, so how you're going to set this problem up is you're going to do F equals KX. That is like the F is equal to the force in either newtons or pounds. K is, I think, how much it weighs or something. Um, but it's in pounds per uh, meter or something like that. Yeah, pounds per meter. And then um, X is will be in like meters or feet or something like that. But anyway, or in this case, inches. So it says, um, so in this case, 10 is equal to F. So you can write 10 equals K, because we don't know that, and then 4 is x. So 10 equals basically. So then solve for k. And 10 divided by 4. It gives you 2.5. So that's what k equals. Well, the amount of work that is done is going to be, it's equal to 1/2 kx squared. And if you think of it, that's just kx. That's just the integral of kx, kx dx. If k is a constant, then if you were to integrate it, you get 1/2 kx squared. So in this case, we want to know 6 inches from its natural length. So we do 6 squared. And then we times it by k, which we found to be 2.5. And then we divide that by 2. And we get 45. And that's, it's 45 pounds, pound inches. So it's like pounds times inches, and that's what the units are. Does that make sense?
I think so.
Did you write it all out on paper as I was like explaining it? Because that's honestly all you do, is you just use those two formulas to find all these things.
Okay.
So let's see if I have this correct. Oh, that's weird. Here, just a sec. Okay. I took a look at the answer key, and the answer was 3.75, and I was like, I got 45. This is bad. But the units are in feet, and so if you do 45 divided by 12, so convert inches to feet, it gives you 3.75. So we got the right answer.
Okay.
So the next problem is asking, so if it's stretched 4 inches, how much work is done when it's stretched an additional 6 inches? And that's the one I wanted to check. Yeah. So we can evaluate it at 10 inches, which is 4 plus 6. So we can do 10 squared times 2.5 divided by 2. And then that gives us 125. Then we can do 4 squared, because we want to find the difference between 4 and 6. So we have 4 squared times 2.5, which is k, divided by 2. And that gives us 20. And so we can do 125 minus 20, and that gives us the evaluation of the integral between 4 inches and 10 inches. And that gives us 105 inches. So to convert that to feet, we get divide by 12 and get 8.75, which is what the answer key says. So do you want to try the next one? So joules it's the unit of measurement for work, which is work is equal to 1/2 kx squared. Although joules are measured in Newton meters, so we have to convert all these centimeter lengths into meters. So since it takes 100 meter, we get 30 centimeters is equal to 0.3 meters. 42 centimeters is equal to 0.42 meters. So this is actually an interesting one. Weasel, can you get me a pen? A pen. So how do you think you'd set this one up?
So
Thanks.
So do you do the 2 squared?
So it's important to identify the variables. So the formula that we're using is W equals 1/2 kx squared, right? In this case, what is W?
W is 2. Or do you want?
W, correct. So 2 joules equals 1/2, and then it doesn't give us K. And then X is an interesting thing because what it really is change in X from the starting point. And so if you read it, it says that 30 centimeters is its natural length. And so at rest, that's 30 centimeters. So stretching it to a length of 42 centimeters is actually only a difference of 12 centimeters.
Was it?
So X is actually 0.12 meters.
Okay.
Does that make sense?
Yeah.
So then our formula ends up being 2 equals 1/2 K times 0.12 squared. So we plug that in, we get we end up with about K equals about 277.78. I'll just round it to that. So then it asks how much work is done from stretching the spring from 35 to 40. So 35 is 5 away, and 40 is 10 away from the natural resting place of 30. So what we can do is we can end up doing 1/2 K, which in this case is 277.78 times, since it's an integral, we want to do the bigger one first. So 10 squared minus 1/2 times 2.77.78 times 5 squared. And so we do 10 squared, which is 100, times 2.77, oh, sorry, 277.78 divided by 2. And then we can do times 277.78 divided by 2. And then subtract the 2. And we end up with a difference of, oh, I was like, why is this wrong? That's because I didn't convert centimeters to meters, which is what I should have done. So this is actually, it's actually 0.1 squared times 277.78 divided by 2. And 0.05 squared times 277.78 divided by 2. And we end up with 1.04 joules of a difference.
Okay.
Which is what the answer key says. Do you have any questions about work so far? Honestly, it's like 2 really simple formulas.
Yeah, the formula then plugging in.
Yeah.
To convert those. Okay.
Mm-hmm.
I think I kind of understand that.
All right, so I'm going to have you set up the next one.
Okay.
So go ahead and read out loud. And I found the easiest way is to identify the variables.
Okay. So a heavy rope 50 feet long weighs 0.5 pounds per feet and hangs over the edge of a building 120 feet high. How much work is done pulling the rope to the top of the building? So to the top of the building, so the edge of the building. So, wait. Is it 0.5 equals okay. On a group meeting. I noticed. Okay. So it's is it no, I don't know. 120 feet minus 50 feet?
I think so. So that equals X.
Yeah.
So then K in this case is 0.5.
It's 0. How come it's 0 point?
That's
For work, and that's the force of it, right?
right. So that's not the force. What that is
Okay.
that's the I can't remember the name
The
for
weight?
it. It's like, yeah, it says that's how much it weighs. It weighs 0.5 pounds per feet. And so we need to do 1/2 times 0.5 times 120 minus 50 squared.
Yeah.
So we start off 120 minus 50, gives us 70. Times that by 0.5, divide by 2. We end up with 17.5. How much work is done on the rope? The top of the rope.
I don't know if I. All right. What? Okay. So do you just times 70 squared times 0.5 divided by 2?
Right, that's how I think it should go.
I got.
Oh, no, okay, I see. What did you get?
1,225.
What did I do wrong? Okay. I was like, I must have typed something in wrong, but so this is interesting. I'm looking at the problem, and what they have you do is they actually set up an integral that's 0.5 times times 50 minus y. And that goes from 0 to 50. Yeah, okay. If you did, would give you 25 minus 0.5y. And then the integral of that would be e to I minus 0.25 y squared, right? No, that's what it should be. Okay, I see what it is. So it's not 120. It's not 120. If you think of it about it, we're only lifting the rope 50 feet because it's dangling off the edge. So the 120 doesn't even matter.
Okay.
Because it could be any distance, but we're only moving the rope 50 feet. And so what it actually ends up being is 1/2 times 0.5 times 50 squared. And so that ends up giving you 625 feet pounds. So then it asks how much work is done pulling half the rope to the top of the building.
So is that just 5?
What's that?
So with the, what is it? The distance be 25?
Yeah.
For that one squared?
Squared. Times 0.5 divided by 2 gives us 156.25. Oh, wait, interesting. Oh. Okay, I see what they did. They're like, okay, what would the work be to, it's like, what's the work to lift the top half, and what's the work to lift the bottom half? And then you add those together. So the top half is, whatchamacallit, is 156. The bottom half is, it's 156. Sorry, I think it's, yeah. So what you can do is you can subtract the answer that we just got, 156.25, from the total answer, and that will give you the correct answer of 468.75.
Okay.
So then the last question is, a cable that weighs 2 pounds per feet is used to lift 800 pounds of coal up a mine shaft 500 feet deep. Find the work done. So we can do 1/2 times K, which is 2, times
it times.
You're just sad. So 2 times 500. So the work done to lift the cable is 250,000. And then the work done for the coal is 1/2 times 800. No. So let's see. I think you have to do 800 equals K 500. And then you get 800 divided by 500. Gives you 1.6. And then if you do 500 squared times 0.6 divided by 2. That's interesting. Because I'm getting a slightly different answer. I'm like 200,000 off. So what I did is I did 800 pounds. So first I had to find the K for the 800 pounds for the rocks of the coal. So I had 800 equals K times 500. So 800 divided by 5 is equal to 1.6. So then I did 500 squared times 1.6 divided by 2, and that gave me 200,000. But the answer key says 400,000, which is if you didn't divide by 2, but you're supposed to. And so I'm just like a little off. But I think, like, I'm pretty sure I did it right, because it doesn't show her work of how she got the 400,000. And so my answer makes more sense to me just because I walked through it. And she would have gotten 400,000 if she hadn't divided by 2. So, but I did the homework already today, and I got all of them right by doing it this way. So I feel good about my answer too. What do you think?
I don't know. I still need to just. This is all brand new, so I just need to watch the videos and stuff.
Yeah.
It's like I can understand the concept kind of and the formulas, but I just need to go over.
So this is what I did. basically, to find the total amount of work done, you find the amount of work done to lift the cable. And then you need to find the amount of work done to lift the coal. So the cable, so do you have the answer key?
Mm-hmm.
So an easy formula for this is the 1/2 kx squared. So we have 1/2. K in this case is 2. And then times x squared. So that's 500 squared. So if we do 500, square it, times it by 2, and then divide by 2, which is just the same, we end up with 250,000, which is the answer that she gets here. That makes sense to me.
Yeah.
So using this, we don't know the K for the coal, so we have to find it. So if we do 800 equals K times X, which is 500, then we get 800 equals K times 500. So K equals 800 divided by 500, which gives us 1.6. So we do the same thing. We do 1/2 times 1.6 times 500 squared. And we get 500 squared times 1.6. And that gives us 400,000, which is what she puts. But you still have to divide by 2, which is 200,000, which would actually give us, once we added that to the 250,000 that we got earlier, would actually give us 450,000 instead of 650,000. So I think it's just like a small little mistake on her part. Cool. Anyway, that was it. Good luck with the homework. Have you taken the exam yet?
Oh, I was gonna ask you that. Yeah, I just got done taking it today.
I'm gonna go take it in just a moment after this. Around like, yeah, I'm gonna take it like in like an hour. So, all right. Well, I will see you next week then.
Okay. Good luck on the exam.
Thanks. Bye.